Getting started with Python is incredibly exciting, and it all begins with understanding the foundation, which is variables and data types, essentially the building blocks of any program. Think of a variable like a labeled box, and just like how we need different boxes to store different items, Python needs distinct data types to process various kinds of information, which is why we're exploring integers, floats, and more. So, to store and manipulate information, Python relies on variables, which essentially act like labeled containers, allowing us to assign and reuse values efficiently. Think of each assignment as a new label, and watch what happens when we run this. The terminal output will display each value, showcasing how Python handles different data types seamlessly. Without variables, Python would struggle to keep track of changing information. So let's explore how these labeled containers help store and manipulate different kinds of data. Think of a variable like a labeled box, where Python stores and retrieves values, making it possible to efficiently reuse and manipulate information. Ability to track changing data would be severely limited. By leveraging these fundamental data types, Python can efficiently process and store information. Think of integers, floats, strings, and booleans as the building blocks of any program. Without variables, Python's ability to track changing data would be severely limited. So let's watch what happens when we run this, and observe how the output reveals the values and data types of our variables. Without variables, Python's capabilities would be severely hindered, much like trying to build a house without a foundation, making it crucial to understand how variables and data types work together. Think of a variable like a labeled box, where Python stores and retrieves data, and without these labeled boxes, Python's ability to track and manipulate information would be severely limited, making variables the backbone of any effective program. Without integers, Python's math capabilities would be crippled. So let's dive into how they work, starting with simple assignments like x equals 5, which lays the foundation for more complex calculations. Think of a program without variables like a chef without ingredients, and watch what happens when we run this, where Python effortlessly stores and retrieves data, performing calculations and printing results with precision. So, with integers like 10 and 20 assigned to variables a and b, Python can perform calculations like addition and store the result in another variable, c, essentially building blocks of more complex operations. Delving into the world of decimal numbers, think of a float like a precise measurement, where Python can handle values like 10.5 and 20.7 with ease, enabling calculations that require more than just whole numbers. Building upon our understanding of integers, think of float operations like a recipe that requires precise measurements, where Python's ability to handle decimal numbers enables calculations that are crucial in real-world applications such as finance or science. Think of division with floats like a recipe requiring precise ingredient ratios, and watch what happens when we run this. The result of h divided by I is 5.25, precisely calculated by Python. Setting up our Python environment is crucial. Think of it like preparing a workspace, where all the necessary tools are within reach, allowing us to focus on writing and running our code efficiently. Think of variables like labeled boxes, where we store values like 5 or 10, allowing Python to recall and use them in calculations, making our code more efficient and organized. By establishing these initial variables and running simple calculations, Python gets familiar with our workspace, essentially calibrating itself for more complex operations. And that's what makes this foundation so crucial. Building on this foundation, Watch what happens when we run this, and you'll see how Python effortlessly recalls and calculates the values of A, B, C, D, and E, printing out the results in a seamless flow. Declaring integer variables like A and B here sets the stage for Python to perform calculations, essentially building blocks for more complex operations. And by assigning specific values, we're giving Python a clear understanding of what we want to achieve. Think of variables like labeled boxes, where Python stores and retrieves values, and by doing so, it builds a framework for more complex calculations, essentially laying the groundwork for seamless execution. Building upon this foundation, Python's interpreter plays a crucial role in executing these calculations, essentially acting like a super smart calculator that recalls and processes the values of A, B, C, D, and E to produce the desired results. Watch what happens when we run this, as Python's interpreter springs to life, processing each line of code and producing a stream of output. 30, 60, 10, 30, and 5. Each value a testament to Python's ability to store, retrieve, and manipulate data with precision. By executing this simple code, Python's interpreter demonstrates its ability to store and manipulate values, laying the groundwork for more complex calculations. Think of variables like labeled boxes, storing values that can be reused and manipulated, making Python's calculations more efficient and accurate. By leveraging variables, Python can efficiently store and reuse values, much like a calculator, stores numbers for later use, streamlining calculations and reducing errors. Watch what happens when we run this, as Python's interpreter springs to life, performing calculations and storing values with ease, yielding output like 8, 15, 8, and 6, demonstrating the power of variables and streamlining our code. By breaking down code into simple, reusable parts, Python can efficiently process and store values, much like a librarian organizes books, making it easier to access and manipulate the information we need. Think of a variable like a labeled box, where Python stores values for later use, making calculations more efficient and reducing errors by avoiding repetitive entries. Building upon this foundation, variables empower Python to store and reuse values, streamlining calculations and reducing errors, much like a mental notebook helps us keep track of important information. Watch what happens when we run this, as Python effortlessly performs calculations and stores values, much like a calculator, yielding output like 8, 15, 8, 6, and 6. By assigning values to variables like x and y, we're essentially creating shortcuts, making our code more readable and efficient, much like using bookmarks to quickly find favorite pages in a book. Think of a variable like a labeled box where we can store a value like the number 5 and then reuse it later, making our code more efficient and easier to understand. By assigning different data types to variables like A, B, and C, we're essentially creating a diverse toolbox, allowing Python to understand and work with various types of information, making our code more versatile and accurate. Watch what happens when we run this, as Python seamlessly handles different data types, assigning and printing them with ease, and we get the output 5, 10, 15, 5, 3.14, hello, 10, 4.14, hello world. So, variables essentially act like labeled containers, holding values that Python can easily access and manipulate, making it possible to write more flexible and efficient code. Think of a variable like a labeled box, where Python stores and retrieves values with ease, making it possible to write more flexible and efficient code by reusing and manipulating these stored values. By using variables, Python can efficiently store and reuse values, making code more flexible and easier to maintain, much like a librarian uses labeled shelves to organize books. Let's put variables into action. Think of them like labeled boxes, and watch what happens when we run this. The terminal output will display the stored values, showcasing how Python efficiently retrieves and manipulates them. By assigning whole numbers to variables like a and b, we're essentially creating a shortcut to these values, making it easier for Python to perform calculations and store data efficiently. Watch what happens. When we run this, the terminal output displays 5 and 10.